Welcome back to Learning Unity with 3D Game Kit. In this video, we're diving into level of detail, also known as LOD for game assets. We'll go over how to create LODs in Maya to optimize performance by reducing the complexity of models based on the distance from the camera. Once we've set them up in Maya, we'll export the assets to configure in Unity to test and ensure everything's working smoothly. So let's go ahead and dive in and get started. So what a LOD model is basically a reduced resolution model. So as we zoom, we can have less and less detail. So to give you an example, if we take something like a cube here, and we take something like a sphere, and we make them approximately the same size. So I'll go ahead and make the cube a bit bigger to represent the sphere here. So now that they're the same size, we can go ahead and experiment with this idea of LOD by focusing our camera on them and zooming out. And at some point, the sphere and the cube are going to look the same. You can see at this distance, I can't tell the difference between a cube and a sphere. So this is an excellent example of what LOD entails. If we take a look at the sphere up close, it has tons of vertices and edges that make it very complex and detailed and make it look like a sphere, whereas the cube is very basic. It's one of the simplest 3D objects we can have, and for a very long time they look different until they don't. So in a video game setting, to save on processing power and rendering, we could in theory make a very far away version of this sphere a cube instead of a sphere to save on data. Now, we've seen that a bit in the 3D Game Kit. When we were working with it and building it, you notice as I move around the level, at one point the platform would be fine, and then all of a sudden it might be shifted and then it would pop back into place. And that's because some of the LODs were screwed up on the models I was working with, either from my own error accidentally moving them or from the design's error. Now, what I want to show you is how we can set those up for our own object here, and in particular for the gate. These are pretty darn optimized. I don't really think there's a whole lot we need to do with these, but we probably can. Now, it's good to come into these and actually create their own groups for them. So I'll start with the lasers here, and I'll hit Control-G, and we'll go ahead and just make this our lasers here. That should be fine, and same with pillars. I'll hit Control-G, and we'll name this pillars. And what we're going to do is alter their naming conventions to accommodate what is going on inside of Unity in terms of LODs. LODs are recognized by having a suffix on these, and that suffix is going to be _LOD and then the number of LOD it is. For the closest LOD, we're going to want to have this set to 0, and what that's going to do is it's going to let Unity know that this is a high detail model. This is the one we should show when we are close up. We can then duplicate this by hitting Control-D to make LOD 1, and this is going to be our middle tier model. Now, here we can actually come in and edit our geometry to have a lower resolution. This object's pretty optimized, so there's not too much we can do. If I go ahead and isolate it here, one of the areas we can cut back on drastically is these. We can make these a lot less detailed. Now, when doing so, you're going to want to activate your UV menu here, so you can see the UVs, and you want to make sure that you're on your texture UV set. So in the last section, we set up a light map. You want to make sure you're on your texture UV set. And what I usually do is turn off the shells and turn on just the edges. That way we can see where the UV edges are. And the reason why is those are edges you don't want to touch and you don't want to collapse, because if you do, it can screw up your textures. But in terms of reducing this curved area we could reduce quite a bit, and I could just come into edge mode and I could just double click to grab these edge loops if I wanted to. Or I could grab these side edges here and I could grab every other edge on these by shift clicking. You have to be careful here, shift click. And we could do something like an edit mesh collapse, which will collapse those down and reduce those. I could do the same thing here to reduce those. And then on this last one, I could either reduce between these or I could even delete that. But I think something like this would be a good start. So either collapsing or deleting edges, whichever one you prefer. What I would go with is whatever one gives the best results. So I might even do a combination of deleting this edge and then maybe collapsing this edge. So we get something that's kind of equal here, and we can go ahead and perform that action. I might even go as far as to do it here, depending on the distance. So that way we get a decent result. Now that's just one corner. We'll want to do it on more, but you do want to check and make sure it didn't disturb your texture too much, so from a distance it looks okay. You can see here it actually applied a hard edge, so sometimes you do need to come in and adjust the normal. In this case, I'll need to come in and soften that And now you'll see that doesn't really have a big impact. What can also be helpful sometimes is setting up that sky dome light that we talked about and having a mapped light to this. In this case, I'll just set up a sky dome light, and we can come into the settings here of the sky dome. If we don't want to bring in an IBL, you can bring in a ramp, and it has a very similar effect to what we see as default inside of Unity, but that will let us get a read on the lighting. So we can go ahead and repeat this process across this model now and reduce these as much as possible. Because this is symmetrical, we can very likely get away with having symmetry turned on, and I actually did. You can turn symmetry on up here. You can see I had it on this side, which saves us some time. And I can just repeat that process somewhat systematically here, deleting this first edge on each of these, and then we can go through the process of collapsing to reduce this. To see the effect this has, though, let me come in here to display, come into the heads up display, and just bring up poly count so we can see the effect here. We can take note of this right now. This is 396 tries. All right. So as we reduce, we can watch this drop. For example, with these edges selected, I can do an edit mesh, delete edge and vertex, and you can see that goes down to 356 tries. I can then come in here and do the collapses that I did on the last one by selecting these corner ones. So we're going over one and then selecting between these two. And doing an edit mesh collapse. You can see now that it's done, it's down to 316. Then I can repeat the process here. On the center ones. Edit mesh collapse. And now we're down to 276. So you can see we've already dramatically reduced this just with a few edits. And we can look for any other areas here that might help with that process. In this instance, I think that's about as good as it's going to get for LOD 1. So we could delete the history on these, and then we could proceed to make LOD 2. I could do so by duplicating this, creating LOD 2. And as you might have guessed, what I'm going to do with these ones is I'm going to aggressively cut back on this area to turn it into just a slope. So that way we get even less vertices here. So we'll do an edit mesh, delete edge and vertex. For some reason that didn't work the way I intended. Let me try that again. Okay, so it's leaving some vertices there, and I don't exactly know why. That's strange. This looks like a Maya bug that I haven't seen before. I don't know why it's doing that, but I had to go back and do that twice. So maybe I clicked something I didn't see there, but we should be able to just get away with something like that. And just make sure your normals didn't get disturbed from that weirdness. But from a distance, that should be fine. We could look for other areas we could potentially reduce at this distance as well. There's not really a whole lot that we could reduce in this instance because this model is so optimized. But one area we might be able to consider is up here. We could consider welding this edge from here over to there, because at a distance that might not look square, and it really depends on how far that distance is. You have to kind of weigh how much you're going to save though. So if I come into target weld here and go to edge and weld this over, maybe in vertex mode since it's not liking to do edge mode there. I also might have to turn off symmetry if it's not liking the symmetry option. Oh, interesting. Tool doesn't want to work. We could also manually force it by overlapping these. That could be part of the issue. You do have to watch out for this. I forgot to isolate select, so I actually ran into the issue where I wasn't seeing another vertice. I was editing my other model. I'm going to undo here back to before I did that second deletion and make sure I'm on my LOD 2 here for this effect and leave my LOD 1 alone. So careful with your selections. Make sure you're using the isolate select wisely here. That way you're not accidentally selecting the wrong mesh and having a weird visual bug. So now that we've caught that, if I use the target weld here, you can see I can weld that in and we can make those top parts shrink in even more. Now at this point you will notice it distorted the texture, but if we're seeing it from this distance, not a problem. You can look for other areas where that might be a feasible solution to do. For example, we may even be able to come in here and do a target weld from here to here from a really far away distance. And this will save us even more data. Now, you won't really know till you get it into Engine So just be mindful of that. But something like that is totally fine. You can see how much that distorts it. But from every angle, that silhouette should hold up. So once we're satisfied with this, we can move forward. I have a couple more welds to make here to make that match up. So let me get those in place. And that looks pretty good. I think at this point, I'm satisfied with these. So what I could do is I could delete their history here by selecting them, edit, delete all by type history, and that will give us our 3 LODs. We have our LOD 0, which is our up-close model, our LOD 1, which will kind of be our mid-distance model, and then our LOD 2, which we should be seeing from far away. The lasers are the last thing that we might consider editing. In this instance, I don't think there's really too much we can do for these, but we could actually do some LODs if we wanted to reduce these down a little. So I'll make this one LOD 0, and then I'll go ahead and duplicate this to create LOD 1. And in this instance, what I would do is take a corner here, and I'll turn off our texture so we can see this a little bit easier by hitting this button here. I could weld this up using a target weld to go to the top point, and we could just remove one of the edges in this area to turn it into a triangle, so that way we reduce this quite substantially. And you'll see once again, every time I do this, we're dropping this by 2 tries, which is decent, and when you think of this over the course of an entire level, that's going to start to add up. So at this point, now we just have 1 row. And then if I go ahead and duplicate this again to LOD2, we can actually go do the other side. Now, for those of you who are 3D veterans, you might be asking, hey, is this going to create non-manifold geometry? And the answer is kind of, but for video games, this works out okay, because what we end up with is 2 polygon faces that have opposite facing normals. And this is a way we can get around the backface cooling. If we come in here and turn on backface cooling, you'll see we see both sides of this without it going invisible. So having these perfectly overlapping is actually a valid way of achieving that. So that could be our final LOD, and basically from a distance, if we look at the 2 LOD2s together, what we're going to see is a flat line, but that should look fine with our emissive texture. We should notice that. And as a matter of fact, we probably could do that anyway for the highest level, but we'll go ahead and keep the 3D depth in there. So at this point, we can delete the sky dome light. We don't need it anymore. We just needed that to check our material interactions with lighting. We can highlight everything, delete the history, freeze the transforms, and once again save. And then we can test this inside of Unity to see if our LODs are properly registering and setting up correctly, which they should be since we've done them correctly. But I do want to isolate these to just talk about the reduction we achieved. On LOD2, we went from 396 to 342. So we dropped it by 54 or so. And then on LOD2, we dropped it all the way down to 216 from 396. So we actually almost cut it in half. So you can see the impact that will have on performance should be very positive. Now, to export this, we just export it like we've done before. We just go to our file game exporter, and this actually will remember everything you had set up, including the location of the laser gate, and we can just click export on top of that and accept, and this should overwrite the data. Now, what's really cool here is in terms of Unity in our scene file, there's a good chance we can actually overwrite this exact object without having to change it and have it update throughout the entire game. The way you would do that is you come into the My Assets folder here, and what I like to do is right-click and click Show in Explorer. This is going to show you where this lives in the file system, and if you want to overwrite it with a new one, what we can do is we can navigate to our game asset folder in Maya, to the section we saved to, which remember is deliverables, and we can drag and drop the new FBX onto the old. So if I go ahead and do this, drag and drop onto the old and replace this, this will replace the source file. Then when I click into Unity, we'll see it loads, and notice that we don't really notice what happened here, but if we take a look at the laser gate, you're going to notice something neat happened. Now that we have the proper naming convention, notice it added this thing here called the LOD group. And in this LOD group, it's going to have LOD 0, LOD 1, and LOD 2 for the respective distance the camera is at. Likewise, if we take a look at this over here in our inspector, we can see that the geometry now has a laser submenu with LOD 0, 1, and 2, and a pillar 0, 1, and 2. So to confirm this works, all we need to do is move our camera, and I'll keep the object selected so you can see this happening. As we move this camera into one of these thresholds, it's going to pop in the next LOD. So right now we're seeing our highest LOD, but if I move my camera here, we should see the next LOD pop in, which is going to be LOD 1. Now, we won't really be able to see that if we've done it correctly. If you've done your LOD correctly, it should look like the same object going between 2 and 1. The one that's a little bit more wild, remember, was that LOD 2 because we made some big changes to the model. So if I go way out here and we get into LOD 2 territory, you can see those dramatic changes we made to the model, but you can see it's occurring seamlessly. So this is a successful LOD result here, where you have a seamless transition. To show you how we can adjust this, you can come in here and use the slider here to adjust the range. So just to make it very apparent, let me go ahead and make all of these within a narrow range here so that we can see them popping between each other and you can see the effect. So here's our highest. As I move here, if you stare at those little laser panels, you'll see here's our lowest. So we can confirm it is actually toggling through these models. And if I move slowly and up close, you can see those changes. But by default, the spacing it gave made it so that as we're zooming out, we don't see those changes at all. And even from a distance, remember, we welded those top areas, we don't see that at all. So now we have an asset that is complete, it's ready to go, and we can start implementing it into our game. It has a nice game-ready mesh that's been optimized. It has a good texture set with bakes. It has a light map UV set, and now it has the final touch, which is those LODs. Now, talking a bit about LODs, I prefer to create mine manually because it gives you complete control and ownership over it. But some pipelines, they do use automatic tools that automatically create LODs, and you can actually look for errors in LODs in video games. There's been quite a few modern video games from big name titles I've noticed where they have noticeable transitions in their LODs. So having an awareness of how to set these up properly, like we've done here, can go a long way in hiding that and making a higher quality product. So at this stage, you now have a well-rounded knowledge of how to take an asset from start to finish in Maya and get it into Unity and set it up to be optimized for games with all the bells and whistles. What we're going to take a look at for our final portion of this section is how we can integrate it into the 3D Game Kit to make it an interactable object in our game using the 3D Game Kit tools. So that's it for setting up LODs in Maya and configure them in Unity. By using LODs efficiently, you're ensuring your game runs smoothly without sacrificing visual quality. In our next video, we will go ahead and take a look at how we can integrate this into our game with actual mechanics. If this video was helpful, don't forget to like, comment, and subscribe for more tips and tutorials. Thank you for watching, and I'll see you in the next one.